Well, hey there, kiddos. Welcome to your video on writing quadratics given the roots. All we're going to do right now is just the opposite of what we did in class. So what we did in class today was we factored a quadratic, then found the roots. Now I'm going to give you the roots. We're going to go backwards and come up with a quadratic. So it's just the opposite of what we did. So number one here gives you the roots, and this is how the notation looks. It just means that the roots are x is -6 and x is 4. I just write them together in a set like that so that I have them both. So this is what it tells me. So just like with what we did today in class, the first thing I have to do is make these two things equal 0. So I can't do anything with a quadratic until it equals 0. So to make this one equal 0, I'm going to have to add 6 to both sides. So I'm going to end up with x plus 6 is equal to 0. And for this one, I'll have to subtract 4 on both sides. So I'm going to end up with x minus 4 is equal to 0. So my two factors for my quadratic are going to be x plus 6 and x minus 4, which is where I have a place down here to write them. So I have x plus 6 and x minus 4. Now there are two ways to approach the multiplication of these. You can use the box, so I can do my x and my 6 here, my x and my minus 4 here, and then I just do like Punnett squares and I go through and multiply. So x times x makes x squared, x and -4 makes -4x, 6 and x makes 6x, and 6 and -4 makes -24. Pardon the bell. Then to write my quadratic, I'll combine these two right here on the diagonal because they have like terms. So this becomes x squared plus 2x minus 24. So this is the quadratic that has these two as solutions. Now if you don't want to draw the box, because I know some of you don't like that and it's just tedious, you can do double distribution. It works the same way. So I'm going to do x times x, which makes x squared. I'm going to do x times -4, which is minus 4x. Then I'll do 6 times x, which is 6x. And then 6 times -4 is -24. And then I can combine my like terms in the middle, so I get x squared plus 2x minus 24. So either way you decide to do it, you will get the same answer. There's room on here for you to have the box and draw the box, but you don't have to use it. You can double distribute instead. So let's do one more like that, and then we're going to do another type of example. So I have solutions, x is -10 and x is -5. So what that tells me is that x equals -10 and x equals -5. So I've got to make both of these equal 0. So I'm going to add 10. So I have x plus 10 is equal to 0. And for this one, I will add 5. And so this becomes x plus 5 is equal to 0. So my two factors are x plus 10 and x plus 5. And again, you can use the box if you want. There is one there for you if you need to draw it and plug everything in. So you have x and 10, x and 5, and then you just go square by square. So x squared, 5x, 10x, and 50. Put your like terms together so you end up with x squared plus 15x plus 50. Or you can double distribute. So you multiply them together. You do x times x makes x squared. X times 5 is 5x. 10 times x is 10x. And 10 times 5 makes 50. Put your like terms together in the middle and you've got x squared plus 15x plus 50. So just like before, they are the exact same answer. Doesn't matter which method you use. So I'm going to skip over here to number 4. We're going to do this example. It takes care of both examples 3 and 4 at the same time. So it tells me that my zeros are x is plus or minus 11 over 2. What that means is that x is equal to 11 over 2. That's supposed to be an 11. It did not come out very well. So x is equal to 11 over 2, and it also means that x is equal to -11 over 2. So they're exact opposites. One's positive, one's negative. So instead of writing down both of them, I combine them into one statement and say plus or minus. That way I know they're both included. Now I've got to make this equal 0, but because it is a fraction, this turns this into a two-step problem. I cannot just add 11 over 2 to both sides and then call it a day. That's not how this is going to work. The fact that this is a fraction tells me that when I get down here to my factors, my x's are going to have a number in front of them. So instead of being like these two, where I had x plus 10, x plus 5, or x minus this and x plus that, this x is going to have a value in front. And so this is a two-step problem. Step number one, we don't want a fraction. I want to clear out the fraction. So to get rid of this fraction, I'm going to multiply both sides of this by 2, because that's the denominator of my fraction. That'll make this side 2x. These 2's on this side will cancel, and that will leave me with 11. Now to make this equal 0, I'll just subtract 11 from both sides, and so I will get 2x minus 11 is equal to 0. That fraction, the fact that it's a fraction, tells me I'm going to have to do both of those steps. And so this one, we're going to do the same step. Let's get rid of that fraction, so we're going to multiply by 2 because that's the denominator. So I end up with 2x is equal to, in this case, negative 11. So I'll have to add 11 to both sides. So I end up with 2x plus 11 is equal to 0. So my two factors are going to be 2x minus 11 and 2x plus 11. And this time I am only going to do the double distributive property, so I don't want to mess with the box. So I'm going to do 2x times 2x makes 4x squared. Then 2x times 11 makes 22x. Negative 11 times 2x makes negative 22x. And negative 11 times positive 11 makes negative 121. And so what happens when I combine these two like terms, because they are exact opposites, is that they cancel. So I just get 4x squared minus 121. This is my solution. This is what gives me that as the roots. And so if you just have one root, you're only going to solve it once. This one has a plus or minus, so you have to do them both. But so you just take it, you make it equal 0, then you multiply your two factors together. So that's how we write equations given the roots. We'll practice this when you come to class tomorrow. I'll see you then.